that we do on a paper with numbers draws something. It's a real picture in real life. So if we can get it off the page and see what it looks like, it becomes a lot more interesting that way. So we're going to go over slope and functions. Okay, what is a function? What is slope? How do we graph these? And then how do graphs move? This is our big picture thought for where we're at for chapter 2. Okay? So the very first thing is a function. Okay. Remember, math. New language. We get all these other words. We have to decode it. Right? So we're learning this new language. Function. Function is another name for y. So every time you see function, I just want you to think y. That's what it is. It can be called y, it can be called g, it can be called h, whatever it looks like. Any equation that I write, y equals 2x minus 1, I can rewrite that as f of x equals 2x minus 1. This is function notation. Okay? So we have replaced y with function notation, but why? Why would we do that? Okay? Because we're trying to solve y. Y is our question mark. We don't know what it is. So in this case, when we write it in function notation, it says y is equal to whatever I plug in for x. That's all it's telling us. It is an instruction guide on what to do for equations. So just keep, that's just a vocabulary thing, so we're not going, oh, I'm learning a whole new concept. We're solving for x and y, okay? Now, we can have all kinds of equations, but all functions are an equation, but all equations are not a function, okay? This is the whole all squares are rectangles, all rectangles are not a square type of thing. Some very specific things have to occur for it to be a function. Now, for this chapter, we are dealing with lines. Okay, there is only one type of line that is not a function. All of the others are functions, okay? A function means that every x value, okay, only has one y value. Okay, so what does that look like visually? Okay, I need to see what that looks like. If I have x equals 2, right here, I only have one y spot for it. I can't have that y spot and this y spot. So I cannot have an equation that looks like that, where one x value, two separate y values cannot exist. Okay? We call this the vertical line test. So if we see a picture and we draw a vertical line through it, and if it hits more than once, it is not a function. Easy breezy. So when we see it visually in a picture, super easy to spot. Can I draw a vertical line through it? Does it hit it more than once? If it doesn't, it's a function. Okay? Graphically, we need to look and make sure that each of our x values only has one y value for it. Okay? So we're going to add some more wording. Okay? So all of these words that I have up here are all equal. So lump them all together. You can copy this chart. This will be on your next test. Okay? These words for it. Okay? So our x values are called our domain. You will see that word terminology used the most. They are also called our input. Why would they be our input? Okay, because f of 1, it's the value that I input into my equation. I put it in the equation to solve another one. So it's the input, it's the domain. It is also the independent variable because it's the one we choose. So it's independent, okay? Which means that our y is our range. It's also the output because if I put x in I get a number for y, so it's what I get out of it. It's my output. And it's the dependent variable because my value for y here is completely dependent on whatever I put in my x spot.
Yeah.
Okay? Does that make sense why those all
Yeah.
are the same? Okay? All the same words meaning the same thing. So input, domain, independent variable all just means x. Output, range, dependent variable all just means y. Other words for it. Right? So
Why would you use f of x instead of using just y?
Because it is the norm for when you are putting in values, so that you can make your tables or that you can make your graph for it, because they will say, what is f of x 3x minus 2 when x equals 4? Okay? So it's just the standard form of writing it.
So how would you solve for f of x?
All you do is plug in x.
Okay.
So it's the same, like we could rewrite this as y equals 2x plus 1. It's just a visual difference of it. You were going to see it written like this. It means y equals 2x plus 1.
Yeah.
F of x means y every time. You might see it as g of x, it might be h of x when they're identifying different equations. This is why we can use different function ones. So if you're graphing 3 different functions at the same time, you can identify them separately. You know, otherwise you've got y equals this, y equals this, y equals this. Okay, so it looks a little different. It's just a written terminology
Okay.
for y. So just think f of x is the same as y.
Okay.
And I have had some students that have always replaced f of x with y. Because visually, they like to just see the y for it. But it's just telling us y equals what when x, we're plugging in x here.
So on that one where you have f times 1, so would y just equal 1?
Nope. This is y equals f when x is 1. So it's an instruction guide. This is the instruction manual. It's saying y when x equals 1. So everywhere in the equation where you see x, you've got to put the number 1.
And then you solve the problem.
And then you
Numbers
solve
again.
it and you get y.
Yeah.
So they'll say, you'll get this. F of 4 x squared minus x minus 1. Let's do plus 1. Okay? And want to solve for this. This is our instruction guide. This just tells you everywhere you see the variable, you're going to put the number 4. So this is the same as y equals 4 squared minus 4 plus 1.
Okay.
So it's learning to read the instructions. We've got to learn what are they talking about before we go anywhere.
So all that one means that there's just that y equals 2 times 1 plus 1.
So y would
Okay.
equal, so if I was making a chart or a table to graph this function, when x equals 1,
What is my y equal?
y equals what?
3?
3. Okay? And if x equals 4, y equals
9.
9.
Yeah, so you just
All right?
Okay, now I get it, yeah.
Yeah, it's just, again, it's just those instructions. All we're doing is plugging it in. And we're answering the question, when x equals this, y equals what? Right? So all the things as we have functions, whether we have linear, quadratic, logarithmic, we are answering that whole, when x equals what, y equals what. Because we're just trying to graph it on a coordinate plane.
yeah.
And we need x and y coordinates the whole time. Okay? All right. So, let's look at a couple of different ones. Here are my x values, here are my y values. I could label my x as what between, is it the domain or the range?
Domain.
Domain. Y is the
Range.
range. So when we are looking added on a coordinate plane. X is your domain. It's all of the x values that graph takes up. It's all of the values that it takes up. Range are all of the y values that it takes up. So if I have this circle over here, my domain is going to be just those x values. That's all the x values that it takes up. Okay? My range is just going to be these y values. That's all the values that it takes up. So when we're looking at our graph, when it's actually on a coordinate plane, that's how it relates. Okay? If we're looking at lines, we know that lines go off into infinity. So what is my domain for this line?
Infinity.
Yeah.
Infinity. All real numbers. And we write it, I write it like this, all real numbers. It's an R with a double line. That's the mathematic notation for all reals. Or you can write out all reals, but if I see that, if you write that in your homework, that's fine. We're on the test, okay? What is the range for this line?
Infinite.
Uh-huh.
Yeah.
All real numbers. Also, okay? If we were to look at a graph that looks like this.
Wasn't that not a, you said you can draw a vertical line through it? Oh, vertical.
Mm-hmm. Yeah, so this is a function, this is a quadratic. Okay, we'll hit that in a couple of chapters. So what's my domain? Domain, all of the x values that it takes up. These go off into infinity.
It'd be infinite then, wouldn't it?
Yep, all reals. What y values does it use?
All positive?
Everything greater than
1.
everything greater than 1. So y greater than or equal to 1. So those are all of the y values that it uses. Okay? Are we seeing how it's just it's just giving us parameters so that if you were to describe to someone how to draw it, they would know what part of the graph to put it on, what it takes up, visually where we're at. Okay, so we've got our domain and our range. We've got this guy. We've got -3, 3. I would rewrite this as a coordinate -3, 3. If I was writing a coordinate form. I have this one. When x is 1, I get an output of -2, and I also have when x is 1, I get an output of 1.
So that can't be right, right?
Correct. I have the same x value with 2 different y values, and then I have 4 and 4. This is a difficult and often difficult concept to grasp table-wise.
Wait, so can you get to y, like, you know, -2 and 1, you can get 2 for just one?
So we're asking, so we're going to look at this one. Is this a function?
Right.
So our definition says only one y value for every single x value. Okay. Sometimes I understand that's a difficult thing to grasp. When we rewrite it as coordinates here, and if I were to graph it, I would say, oh, when I graph at 1, I'm graphing a -2 and a +1. I have 2 points right on top of each other on the same exact
Slope.
same exact x value there. So I can't draw a vertical line through there. I'm hitting 2. It is not a function. So when we have one x value that goes to 2 separate y values, it will not be a function.
But if, say the y value was,
So let's look at this one.
yeah.
I have 2 separate x values that go to the same y value. Okay, so then we're like, oh, well, it's on the same ones again. What is that? Okay, so let's look at it. We have -3, 3. I've got 1, 1, 3, 1, and 4, -2. Am I repeating any x values? No. As long as we don't repeat any x values, it's a function. If I were to graph this, it just happens to be a straight line here. They have the same y value. But I could graph this like that and still make all my vertical lines. It's a function. So what we're looking for is single x values. We don't want a duplicate
Okay.
of an x value. Okay? Single x values. It's okay if we duplicate y's. It is not okay if we duplicate x.
Okay.
Any extra questions about that?
Yeah.
This is one of the most difficult concepts to grasp because it's that transition between numbers to a picture.
I feel like I usually have an easier time doing this than like chapter 1. I'm just not like a super good person at just algebra. Like
Well,
this, a lot of the times I'm better at just graphing simpler equations.
we'll get there, and that's what algebra helps us do. We need to do that so we can find the equation,
Yeah.
you know? Right, so if we're looking at it in function notation, okay? First off, for function notation, we are answering the question, what is y? We cannot answer the question, what is y, if our equation is not written in y equals, okay? So first we're going to look at this the equation written as y equals. So if we see 2x equals 1, all right? If there is no y in your initial equation, if we get a 0 on the other side, we can replace the 0 with a y, okay? And the reason for that is because we get to answer the question when y equals 0, x equals what? It gives us our y-intercept on our graph, on the coordinate plane. Okay? Sorry, it gives us our x-intercept. When y equals 0, we're down here, x equals what? It will be the part where the graph crosses, let me do a quadratic, where it crosses the x-axis. Okay? This is important to know. So we are saying when y equals 0, x equals what? So there's one for a quadratic. Here's one for a line. When y equals 0, x equals what? These are your solutions. Okay? So as we move through this entire year, your solutions are where your graph crosses your x-axis. That's what we're looking for. Okay? So these are, in business, these are our break-even points. These are our profit margins. You know, it's that we're looking for where it's crossing, right? So I rewrote this. I moved the 1 over, so I've got 2x minus 1 equals 0. Now that I have a 0, I can just replace that 0 with y. Okay, so once we get a 0, if it doesn't start with a y, we can add a y as long as we end up with a 0 on one side. Okay, so then we can just make ourselves a chart. Does each x value have only one y output? You know, this is the base. We're learning the chart version before we're just putting it on a graph. And I could plug it in and go, oh, when x equals 0, y equals, x equals 0, it gets rid of the whole thing. So y equals negative 1. If x equals 1, 2 minus 1 is 1. When x equals 2 equals 3, we can see that it's always going to be adjusting. So is that ever going to have a duplicate? No, it's not having a duplicate. Okay, so that's a function. We can then graph and plot those points and see that indeed we do have a line, and it's going to pass the vertical line test. So it's a function. Okay? Remember, as we start looking at them, you've got a parent function sheet that I gave you. It will fold up. We will work on this same one as we go throughout the year, so I want you to glue it, fold it, and glue it into your binder. You can fold it if you want, or you can glue it in flat, either way, whatever you want to look at it. And we will just keep adding information to it as we go throughout the year.
Did you say we're allowed to use our notebook on
Yes,
tests?
this one, yes.
Yeah.
Yep. Okay. So, just note, the exponent tells us how many solutions we could ever possibly have. A solution for what? Solution is where it crosses the x-axis. The exponent of this x is an unwritten 1. At the most we could ever have is one solution. We don't have to have one, but the most we could ever have is one solution for it. Okay? So we're going to start reading all of these equations. Every part of the number always gives us another clue to what we're going. So what should it look like? Oh, it should look like a line. How many times could it cross the x-axis? Only one. Okay? All right, so functions can look like a lot of different graphs as long as there's only one y for each x value. So let's look at these. All of these are functions because I can draw a vertical line through every single one of them. Okay, even this one here. So each, if I pick x is -2, I only have one answer. Okay. Now on this one, how many solutions does this graph have?
Infinite? Well,
If we're looking at our y equals 0, how many times does it cross the x-axis?
once.
1. So it would be a one solution in the terms of when we are finding the solutions of our functions where it's crossing. How many would this one have?
On the x-axis,
Mhm.
just one, right?
1. So this is going to be an x equals. This is going to be an x. Okay. How many solutions does this have?
2.
2. So it's going to be x squared. It would be an x squared equation. This one looks funny. How many could it have?
Just one.
What if I bent this part down and did like that?
No, 2.
Oh, how many does
Or
it have?
3. 4. Wait, no, 3.
1,
3.
2, 3. That's an x cubed. How many does this one have?
4.
4. Okay. So this is where we start visually seeing, oh, our lines make sense with whatever my values were. So we can start plugging in. Go. I think I kind of know what that looks like. So even if you've never seen it, you go, oh, I know what these numbers mean. Yeah, so we're starting to use our logic. Connect those points together. Okay? So all lines, so all y equals x of something are functions except a vertical line. Right? Can a vertical line pass the vertical line test? No. Because if I have my x and y chart, if x equals 1, y equals -4, x equals 1, like,
All the way down.
it's all the way through it, correct?
Yeah.
So vertical lines are written as x equals a number. Because it means no matter what y is, x equals 6. So when we have an x equals a constant, it is a vertical line.
But there's no y value.
There's infinite.
Well,
y
yeah,
values.
yeah, but like
Okay.
not one particular.
Yeah. Now, if I change that and say y equals 6,
Then it would be infinite,
Yeah.
horizontally.
because that just means it goes that way. So is it a function?
Yeah.
Yeah. We also can see that it's a function because it has a y in it. Right?
Yeah.
Yeah. And the reason in our, let's look at this one, x equals 6. So if we're trying to move this over, we've got -6 equals 0. Is that true? Remember we were trying to get a 0 to get a y, to replace 0 with y? But -6 is not equal to 0. So we've got a couple of different ways, but typically just graphing it. Y equals our functions, that x equals a constant is not a function. Alright? So we've already went over this, that y and f of x is the exact same. It's our instruction guide telling us that whatever is inside that parentheses is what goes in wherever we see a variable. So even if I have g of 2 equals z squared minus 4, and we use different variables,
It's still gonna be whatever.
It'll
the
be
this
Two-
goes where the variable
Yeah,
is.
so 2 squared, so 4.
Uh-huh.
So 0
0.
equals y.
Y equals 0. So when z equals 2, y equals 0. Okay, so no matter what the variable is that they use, it's just telling us put this number where you see a
So when
variable
y
on the other
equals
side.
0, would it be just a straight up vertical line?
Well, that was for that specific point.
Yeah,
So when y equals 0,
right in the middle.
then the other one was 2.
Yeah,
Right.
so it just goes straight.
Well,
vertical.
that's a point for that equation.
Okay.
We would have to
Right.
solve for more of them,
Yeah.
depending upon what we've got. Okay? Alright, so again, we've got y equals x plus 1. We could rewrite that as f of x equals x plus 1. Right? If we were going to plot ourselves some points, we would give us x and y, and we would just start picking which one is our independent variable. Independent. It's the one that's choosing. It's independent.
The x.
The x, right? So we are going to pick values for x, okay? And then y depends upon whatever we pick for x, okay? So we are always solving for one particular point at a time when we're plugging in those x values. Okay, so, but because we've got this y equals, we have a line, we're looking for all the different values. It's not just a single one. So that's why we're getting those lines. We're looking at our infinite numbers, okay? So we can make a chart and then plot a couple of different points, okay? The ones that are super easy to find, that we're always going to look for, are where it crosses the x and the y axis. So the x axis is always when y equals 0. The y axis is always when x equals 0. Correct? So we ask those questions. This one is, the y axis is called your y-intercept. Your x-axis is your x-intercept. It is where the graph is intercepting that axis, right? I mean, at least we can use our normal terminology for that. If you're throwing a football and you get an interception, it's part of which it crosses,
Yeah.
right? Okay, so we find our x-intercept by asking when y equals 0. We find our y-intercept by asking when x equals 0. You will hear me say this for the next 9 months. When x equals 0, y equals what?
0.
Okay, so we'll just be talking all the way through. I'm like, when x equals 0, y equals what? Or when y equals 0, x equals what? We need to know which part of the graph that we're doing. So we're just plugging in, and then we would graph along the coordinates. Right? So here's a couple of more examples that we have. We've got y equals 4x. Could rewrite it, f of x equals 4x. Correct? So when x equals 1, y equals 4. When x equals 2, y equals 8. X equals 3, y equals 12. These are individual. Is this a function?
Yes.
Yes, it is a function. Okay, because it's a function, we can rewrite it in this function notation. Right? So let's look at this one. It has an exponent of 2, which means the line has bent once.
Yeah.
Okay, so taking a line, all lines, exponent of 1, all lines means the most it could ever cross the x-axis is 1 time. This one, exponent of 2, the line bends once. The most it could ever cross the x-axis is
Please.
twice.
Does it have to cross it 2 times?
No,
Okay.
but the most that it could
It's 2.
is 2. The most, so you could have 0, 1, or 2 solutions for it. So let's plug that one in. When x equals 0, y equals 0. It starts at the origin. And then we're going to keep going up. Okay, so if we look at just the positive side, we've got a nice little curve over here. Right? It's actually an exponential equation. But we're going to use some negative values because when we square negative values, we get a positive. Right? Every negative times negative equals a positive. So we're going to get the same values, same y values. We have a parabola. Okay, this one has one solution where it crosses the x-axis. Right? It is a function because it passes the vertical line test. That way. Right? We can also see that although graphic table-wise, we have repeating y values, but we never have a repeating x value.
Yeah.
So on the table, we're looking, we don't want repeating x values for it to be a function. All right? The terms linear. Why do you think they called it a linear equation? It makes a line. These are called quadratic or parabolic functions. Okay? Because it makes a parabola. Okay? And when we get into it, I'll explain a little bit more of the quadratic, why they use that terminology. So let's look through this. Number 1, function or not?
No.
No.
Yes.
You agree? Okay.
Yes. No.
Oh, it's coordinate plane, so it's just one line.
Oh, yes.
Okay.
No.
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 Well, there are 2 points that.
No,
if the line
I'd
went
say
through.
no.
Okay, so let's look at this one. We have 2 points on the same line, but what does this open circle mean?
Not
It's
equal
not
to.
equal
It's
So-
not equal to, and a closed circle means
It is.
it is equal to. So are there actually 2 points
No.
contained on that vertical line? No. This is a function because this is called a piecewise function.
Okay.
We will hit that at the end of this chapter. Piecewise function meaning for the x values less than this one, we're going to use this equation with a negative slope. And for the x values greater than or equal to 1, we're going to use a second equation with this positive slope on it.
Okay.
Now, if they were both filled in,
Then it would not be.
not a function. Okay, but they're not, so it is a function. Excellent. This one, repeating x values?
No.
No. Function or not?
Yes.
Okay. Repeating x values?
Yes.
Yeah.
Function or not?
Definitely not.
Not. Repeating x values?
No.
No. Function?
Yes.
Yes.
Okay. Let's check. Good job. Okay, so 1, 5, and 8 were not a function. Excellent. Right. So, on our big picture for it, I've given you guys your parent function charts. These are functions that we are going to explore this year.
Okay.
Okay? So we're going to hit them in different chapters. We'll keep referring back to it. It is important that we keep this one and we can keep adding information back to it. You definitely want to have it in your interactive notebook. Okay? So the one that says linear, okay, there's a couple of things that I want you to write in and around, however you would like to write it on that. It tells you f of x equals x, right?
Mm-hmm.
Okay. So you can write y equals x above it if you need to. I would like you to write y equals ax.
Yeah.
Also, either on the same one or around it. Okay. Then I would also like you to write y equals ax plus c. Actually, let's change that to b because they're going to use that for y intercept ax plus b. Sorry, that's why I use pencils, right?
Mm-hmm.
Okay. What we have done is just written all the different ways that we can see this linear
Mm-hmm.
function, right? So these are all the ways that we can look at a graph. We can have it where it's just y equals a number, right?
Yeah.
Y equals any number is going to give us a horizontal line. We're going to start there, have this horizontal line across, okay? When we have the a value in this, what is our unwritten a value?
That's, well,
One.
it's
1, right? Multiply, Okay? Our A value is the slope. So I want you to write A equals the slope. So the coefficient, you can also write, if you want, A is the coefficient of largest exponent variable. Okay, so however, just extra things if you want to write it in there. So if I end up with something that's rearranged like this, I like to say we go in order, like this would be 2, 1, none. We're always going to start at the bottom, but we could look at this and go, my A value is not 1 just because it's at the beginning. My A value is 2 because this is my largest exponent for my variable, okay? So our A value, once we rearrange, it will always be that first number. But if it's not, remember it's the largest one, okay? So what's so important to know about that? This A value tells you a lot of information. It is the same information for every single one of those graphs on there. So if we can decide what does A do, we have information for the entire rest of the book. We have information for something on the ACT that we've never ever seen before. It's always the exact same information, okay? A tells us the slope. It tells us the direction and the steepness of every single function, okay? It's gonna give us information. It's opening that lock. It's giving us a little bit more clues, right? Now, the B value is a constant. So I had written C initially. So our B value, sometimes if it's 0, we don't need to write it, right? So that's why they have the whole f of x equals x like that, because it just means we have this 0 added on to it. Our B value, let's look. If I have y equals 2x plus 0, when x equals 0, y equals what?
0.
Okay. Now, if I change this B value, when x equals 0, y equals
1.
Okay. Change it again. When x equals 0, y equals
-5.
Okay. What is it doing to my points? What direction are they moving?
Well,
I mean,
vertically.
Yeah, vertically.
Yeah.
So our B value always moves our graph vertically for every single function of any type of graph. Our constant, a constant added on to the end, separated from x, will always move our graph up or down vertically every single time for every single graph. And we'll play around with some stuff later, so you can see that. Okay, so now that we know what those numbers do, then it helps us understand it a little bit better, okay? So this is just a copy of what you guys already have on there. All right, so linear functions. A linear function will never have a variable raised to a power. It can't be a line because this exponent tells me I had to bend my line. So it will always just be an x equal for it. And it is always a constant relationship between two different points. We call it the slope. You know, slope style, I have my little ski Olympic snowboarding. So the slope tells you how much it goes downhill. So if you're on the bunny slopes, my slope is closer to 0, you know, because flat ground is 0, okay? So the higher my number gets, the steeper my line gets. We're going to keep moving it, right? The lower my number gets, the lower it gets. Okay, back closer to 0. The constant one that you want to know is y equals x. This is your parent function. Y equals x is a 45-degree line where the slope is equal to 1. That means I go up 1 over 1, up 1 over 1, okay? This is the place to start with our parent function. So that's why it's called the parent function worksheet. This is like basic. I'm not adding anything else. This is where we always start. So if my slope starts going up and I have 4, that means my line is going to get steeper, right? If my slope goes down, how can I make that slope less than 1? There's 2 different ways I can make it less than 1. What's one way?
You can multiply it by a negative.
It can be negative. So y equals negative x is the parent function in the exact opposite direction, right? What if I say 1/2? It's still positive, but it's less than 1,
Yeah.
right? So that's going to be everything below the parent function to the horizontal, right? So all of these right here are going to be fractions. And all the slopes up here are going to be positive number, like positive multiples of it, right? So same thing. Everything down here is going to be bigger multiples of a negative, right? And everything in here, in this space, are going to be fractions, negative fractions. So we can start seeing what space should it be in. Did I graph it in the right spot? Okay. So, in your notes, these 5 ways are ways that we're going to learn about slope. I said we will have notes following for each of these ways, so copy this list down and leave room for examples if you're writing it in your notes. Okay? So, what makes slope so very hard? I just wrote all the things, right? Because it has all the things. There are 5 different ways to find slope. I have color-coded them, so if you go back and look at these slides again, you can find the slide that is color-coded to this one. But we can find slope through a table. We can find slope from a graph. We can find slope if we just have 2 separate points. We can find slope if they give us a verbal description in a word problem, or if they give us an equation, we can find the slope. Okay? So we're going to work through all 5 of these, and then I want to leave, we're going to go a little quickly through this because I want to leave room for our activity that we have, right? So, these words all mean the same thing. Slope, rate of change, ratio, rise over run. You will see all of that. All of it means slope. So when they see what is the rate of change, think slope. What is the ratio of this? Think slope. So again, verbal things. Let's tie all it together. It's not 85 different things. It's 2.
Yeah.
2 things, okay? So slope is always read from left to right. There are 4 of them. We're going to write our slope dude in our interactive notebook. There's a negative, a positive. Negative means from left to right, I am going downhill. My next number is less than, my y value is less than it was before. Positive, we are going uphill. 0, we've got flat ground, undefined, straight line, horizontally. Here is our slope dude. Draw this in your interactive notebook. I have him drawn nice and big right here.
I think I left mine at home.
Okay, just draw on a sheet of paper.
Yeah.
Okay, so here's our little slope dude. It helps us remember the directions. So we have positive and his eyebrows going up. We got negative, his eyebrows going down. Undefined with his nose, this U helps us, undefined. His nose there, and our 0, I put little zeros on the end. 0 is his mouth, okay? We got it? There's our slope dude. He helps us know which direction we go, okay? Now, on your sheet of paper, We're gonna write your name first. I don't want you to define everything because it's the rest for your homework. I want you to do it for homework. You need to write, we're gonna take about 3 minutes, and we're going to write our name with only straight lines. You have you have long name.
Yep.
Sorry. Okay, you have to either write it small or shorten it. You don't have to do all your letters if you don't want to. Okay, so on your grid line, write it big enough that you can do just straight lines. So like, you might do that for a J, or you could do that for a J. However you choose to do it, I don't really care. Okay, we're doing just straight lines. Yeah, those are fine.
Okay.
Yeah, it can be a diagonal. See how I have my A's here.
Okay.
Okay. So what you're going to do is then identify which areas are positive and negative, 0 or undefined. Okay? And you can just write P, N, Z, and U if you want. But the top of your J would be a what?
0.
Yeah. So that part would be 0. I did mine in little highlighted colors. Whatever's coming down, the straight line downs are going to be your undefined. Okay? Okay. So this is a good way to look at our names and help practice our different slopes that we've got. Right? So what is slope? Slope is rise over run. Every single time. If you are sitting in your chair, how are you going to get out that door? You have to stand up first and then walk there. We always stand up first. We always rise and then we run. Okay? So quick reminder, hopefully this is coming back to you. Rise over run, how far do we go up? Over how far do we go across? We pick 2 points, and we're going to take the difference between those 2 points for our y values, the difference between them for our x values. So what that ends up looking like is the difference. Difference is subtraction, right? So the difference between our y values, because that's our up, over the difference between our x values, that's our run, gives us slope. They call slope M. Right? So to have it, we need 2 coordinate points. Right? I have written a note. Often a big deal is made about what order you subtract them in. It has to be the second one minus the first one. Okay? Really, it doesn't matter. I'm going to, mess your math up here. It doesn't matter as long as you go in the exact same order. Just pick one. So in this case, I have 1 and 2, coordinate 1, 2, and the coordinate 4, 8. If I pick this guy to be the first one, I would have 2 minus 8 and 1 minus 4. I've got to go in the same order. I've got to pick the first one. If I change it and I pick this guy first, then I have 8 minus 2, 4 minus 1. You can see that when we work this out, they both equal 2. You're going to get the same value both ways. Just one, you'll deal with more negatives than the other. Okay? So, I don't care what direction you go with them. I usually pick whatever direction is going to give me a positive number on the bottom. Because I don't like working with negatives. Okay? If we have slope from a table, so that first little color-coded guy, we have slope from a table. How do we find the change? Well, we've got to look at just the y's. We're looking at the change in y. So from 10 to 8,
It's
it was minus 2. From 8 to 6, minus 2. From 6 to 4, minus 2. Now, we have the same change. So is this going to be a constant? Yeah, straight line. Yeah, it should be. If my numbers keep where I don't get the same ratio across, we don't have a straight line.
Yeah.
Okay? then my change in my x's from 1 to 2 was positive 1, 2 to 3 was positive 1. So if I write it, change in y was negative 2, my change between each x was positive 1, the slope here would be negative 2 if we were to graph it. Okay? Slope from a graph. I'm just going to find 2 points and then count. So again, my change in y, I go from 10 all the way down to 2. My change was negative 8, right? If I go from 1 all the way to 5, my change was positive 4. So I've got negative 8 divided by 4, I've got negative 2. Okay? And it's going down. It's steeper than my parent function of 45 degrees, so that makes sense. It should be up, right? Higher. Okay, so there's from a graph. Now, same thing, slope with 2 coordinate points. This is all the same graph. We're looking at a different one. So now they give me a couple of different coordinate points. I took these from that chart. Change in y. We're going to pick whatever 2. So I did 10 and 8. Gives me 2. 1, if I pick this one, it's 1 minus 2. So now I have my negative 1 on the bottom, and I get negative 2. I picked these 2, and I still ended up with negative 2. So we're looking change in y or change in x. Okay? From a verbal description, what is the rate of change? Rate of change means slope. They're just asking you, what is the slope? When the change in y is negative 2 and the change in x is 1. We would just plug it in. Change in y negative 2, change in x 1. My rate of change is negative 2.
Yep.
All right? In an equation, when we've combined all of our x's, we've combined all of our like terms, your slope will always be the coefficient of x, or the coefficient of your variable. All right? The other values don't matter, because what do those other values do? Just move the graph up and down, but it doesn't change the steepness of the graph. So our slope is always just that first one. So there's a bunch of different ways that we can find all of those, okay? Something that's important to know, okay? When we have the slope of a line, if we want to make a line that is perpendicular to it, meaning it has a 90-degree angle, right? The perpendicular is the negative reciprocal, okay? We're wanting to get back to the value of 1, right? So if I have negative 2, how do I get back to that identity? So I would have that, but it's got to go in the opposite direction. So I'm going to make it positive because one slope is going to be positive, the other slope is going to be negative if you have it perpendicular. So can we have perpendicular slopes if they're both positive?
No.
No. Now, if I have 2 slopes that are exactly the same, meaning the direction of them are exactly the same, those lines are,
Perpendicular.
their slopes are exactly the same. They're parallel,
Parallel, yeah.
right? This is a handout that I've got that you can print if you want. Okay, this is just re-going over slope is called your M value. Your B value is that constant. It's what changes up and down. It is your y-intercept.
Okay.
Why? We ask that. Because when x equals 0, that's how we always find our y-intercept, right? We answer the question. When x equals 0, y equals what? When x equals 0, y equals 12. That's why it's called the y-intercept, because I just get rid of the x.
Yeah.
Okay, so it is called your y-intercept. So hopefully this is a review and it's helping you go. Remember, we're at the place to where all of our signs travel with our numbers. So if there's a sign in the front, it travels with our number. This is rise of 3, run of 4. We can plot anything according to our slope stuff. Okay? So we are going to do a matching activity. I've got it on the back table. And then I'm going to show you, so we've got time to do that, I'm going to show you a couple of things that I have for your homework as well. 1, there is an assignment for you to join the Desmos classroom.
Okay.
It is, let me get out of this. Hold on. There we go. Come on. There we go. So make sure and join that because I will assign different things. Right now, we're just going to kind of play with it.
Wait, where is this on Google
It
Classroom?
is, and the
Okay.
link is actually on your syllabus
Okay.
on Google Classroom too. So this is an activity. Desmos is wonderful for visually putting in, this is what I'm actually doing. I'm like, play on it as much as you want, okay? So this is a fun activity. It's called the Get the Stars one. The goal is to get rid of all the stars, like that. See? So it's fun. The way that we do it, let's look at this one. Okay, so on Desmos, you can put in any equation on the left side, and it will get it and it will graph it over here. The end of this chapter will be an art activity used on Desmos, where we're going to draw some stuff. Okay, so we're kind of getting used to it. We know that the m value changes the steepness, and our constant here raises it up or down. So if I want to get all of these stars, what do I need to do to this line?
Lower it down.
I need to lower it. What do I think I need to lower it to?
It would be
Just
negative 2.
Let's see. Oh, look at that! All right. Good guess. Click launch. We got all the stars.
Cool.
Yeah.
Okay? So then the next one, it'll give you some information. So I've got to get those. What are some things I need to do to this one? First off, the line is way too steep.
Yeah.
So which value do I need to change? The
X?
4 or the 3?
Before.
The 4.
Yeah.
So Josiah, what do you think we should change that 4 to?
Try 2.
2. Okay. Does that look?
No. So maybe 0.
Try negative 6.
-6.
Oh, that's well, okay. Yeah.
Okay, what if we just do 1? Oh, not quite. What if we do
-1.
1/2?
Oh.
Remember, we can
Yeah.
keep going and still be positive. Does it look like it's in about the right spot?
Yeah.
Yep, and we're going to click launch. So this is a great tool. I really want you guys to do this one because it helps you start picking those numbers and seeing
Start figuring
what
it out.
moves and where it moves, and then we
Yeah.
can get a real great idea for that, okay? You will have this slope riddle puzzle, so it's a worksheet for your homework. We've got that one to complete, and then there is a Google Classroom assignment. When you click on it, it'll pull it up like this.
Yes.
And this is just a drag and drop. So we're just going to drag, maybe, drag